Lake Tahoe is a large freshwater lake in the Sierra Nevada of the United States, at a surface elevation of 6,225 feet. It straddles the border between California and Nevada, west of Carson City. Lake Tahoe is the largest alpine lake in North America. Its depth is 1,645 feet, making it the second deepest in the United States after Crater Lake. Additionally, Lake Tahoe is the sixth largest lake by volume in the United States at 122,160,280 acre-feet, behind the five Great Lakes. The lake was formed about 2 million years ago and is a part of the Lake Tahoe Basin, with the modern lake being shaped during the Ice Ages. It is known for the clarity of its water and the panorama of surrounding mountains on all sides. The area surrounding the lake is also referred to as Lake Tahoe or simply Tahoe. More than 75% of the lake's watershed is national forest land, comprising the Lake Tahoe Basin Management Unit of the United States Forest Service. Lake Tahoe is a major tourist attraction in both Nevada and California. It is home to a number of ski resorts, summer outdoor recreation, and tourist attractions. Snow and skiing are a significant part of the area's economy and reputation. Mountain and lake scenery are attractions throughout the year. The Nevada side also includes large casinos. Highways provide year-round access to the area. Geography. Lake Tahoe is the second deepest lake in the U.S. with a maximum depth of 1,645 feet, trailing only Oregon's Crater Lake at 1,949 feet. Tahoe is also the 16th deepest lake in the world, and the 5th deepest in average depth. It is about 22 miles long and 12 miles wide and has 72 miles of shoreline and a surface area of 191 square miles. Approximately two-thirds of the shoreline is in California. The South Shore is dominated by the lake's largest city, South Lake Tahoe, California, which adjoins the town of Stateline, Nevada, while Tahoe City, California, is located on the lake's northwest shore. Although highways run within sight of the lakeshore for much of Tahoe's perimeter, many important parts of the shoreline lie within state parks or are protected by the United States Forest Service. The Lake Tahoe watershed of 505 square miles includes the land area that drains to the lake, and the Lake Tahoe Drainage Divide traverses the same general area as the Tahoe Rim Trail. Lake Tahoe is fed by 63 tributaries, which drain an area about the same size as the lake. Half the water entering the lake is rain or snow falling directly on it. The Truckee River is the lake's only outlet. The Truckee flows northeast through Reno, Nevada, and into Pyramid Lake, Nevada, which has no outlet. Only one-third of the water that leaves the lake leaves via the Truckee. However, the rest evaporates from the lake's vast surface. The flow of the Truckee River and the height of the lake are controlled by a dam at the outlet. The natural rim, at which the lake can be allowed to flow out through the dam, is at an elevation of 6,223 feet above sea level. The maximum legal limit to which the lake can be allowed to rise in order to store water is at an altitude of 6,229.1 feet above sea level. Natural history. Geology. The Lake Tahoe Basin was formed by vertical motion faulting. Uplifted blocks created the Carson Range on the east and the main Sierra Nevada crest on the west. Down-dropped blocks created the Lake Tahoe Basin in between. This kind of faulting is characteristic of the geology of the adjoining Great Basin to the east. Lake Tahoe is the youngest of several extensional basins of the Walker Lane Deformation Zone that accommodates nearly 12 millimeters year of dextral shear between the Sierra Nevada Great Valley Block and North America. Three principal faults formed the Lake Tahoe Basin. The West Tahoe Fault, aligned between Emerald Bay and Tahoe City, and which is the local segment of the Sierra Nevada Fault, extending onshore north and south of these localities. The East Tahoe Fault, aligned along the eastern shoreline, and the North Tahoe Fault, which runs between the two others deep under the northern part of the lake. The West Tahoe Fault appears to be the most active and potentially hazardous fault in the basin. A study in Fallen Leaf Lake, just south of Lake Tahoe, used seafloor mapping techniques to image evidence for paleo-earthquakes on the West Tahoe and revealed the last earthquake occurred between 4,100 and 4,500 years ago. Subsequent studies revealed submarine landslides in Fallen Leaf Lake in Lake Tahoe that are thought to have been triggered by earthquakes on the West Tahoe Fault, and the timing of these events suggests a recurrence interval of 3,000–4,000 years. Some of the highest peaks of the Lake Tahoe Basin that formed during the process of Lake Tahoe creation are Friel Peak at 10,891 feet, Monument Peak at 10,067 feet, Pyramid Peak at 9,984 feet, and Mount Talek at 9,735 feet. The North Shore boasts three peaks at 10,000+ feet: Mount Rose, Houghton and Relay Peaks. Mount Rose is a very popular hiking and backcountry skiing destination. Eruptions from the extinct volcano Mount Pluto formed a dam on the north side. Melting snow filled the southern and lowest part of the basin to form the ancestral Lake Tahoe. Rain and runoff added additional water. Modern Lake Tahoe was shaped and landscaped by scouring glaciers during the Ice Ages, which began 1 million or more years ago. Soils of the basin come primarily from andesitic volcanic rocks and granodiorite, with minor areas of metamorphic rock. Some of the valley bottoms and lower hill slopes are mantled with glacial moraines, or glacial outwash material derived from the parent rock. Sandy soils, rock outcrops and rubble and stony colluvium account for over 70% of the land area in the basin. The basin soils are generally 65 to 85% sand. Given the great depth of Lake Tahoe and the locations of the normal faults within the deepest portions of the lake, modeling suggests that earthquakes on these faults can trigger tsunamis. Wave heights of these tsunamis are predicted to be on the order of 10 to 33 feet in height, capable of traversing the lake in just a few minutes. A massive collapse of the western edge of the basin that formed McKinney Bay around 50,000 years ago is thought to have generated a tsunami wave with a height approaching 330 feet. Climate mean annual precipitation ranges from over 55 inches for watersheds on the west side of the basin to about 26 inches near the lake on the east side of the basin. Most of the precipitation falls as snow between November and April, although rainstorms combined with rapid snow melt account for the largest floods. There is a pronounced annual runoff of snow melt in late spring and early summer, the timing of which varies from year to year. In some years, summertime monsoon storms from the Great Basin bring intense rainfall, especially to high elevations on the northeast side of the basin. August is normally the warmest month at the Lake Tahoe Airport, with an average maximum of 78.7 degrees Fahrenheit and an average minimum of 39.8 degrees Fahrenheit. January is the coolest month with an average maximum of 41.0 degrees Fahrenheit and an average minimum of 15.1 degrees Fahrenheit. The all-time maximum of 99 degrees Fahrenheit was recorded on July 22, 1988. The all-time minimum of -29 degrees Fahrenheit was recorded on December 9, 1972, and February 7, 1989. temperatures exceed 90 degrees Fahrenheit on an average of 2.0 days annually. Minimum temperatures of 32 degrees Fahrenheit or lower occur on an average of 231.8 days annually, and minimum temperatures of 0 degrees Fahrenheit or lower occur on an average of 7.6 days annually. Freezing temperatures have occurred in every month of the year. Ecology: vegetation in the basin is dominated by a mixed conifer forest of Jeffrey pine, lodgepole pine, white fir, and red fir. The basin also contains significant areas of wet meadows and riparian areas, dry meadows, brush fields, and rock outcrop areas, especially at higher elevations. Ceanothus is capable of fixing nitrogen, but mountain alder, which grows along many of the basin's streams, springs and seeps, fixes far greater quantities and contributes measurably to nitrate N concentrations in some small streams. The beaches of Lake Tahoe are the only known habitat for the rare Lake Tahoe yellowcross, a plant which grows in the wet sand between low and high water marks. Each autumn, from late September through mid-October, mature kokanee salmon transform from silver-blue color to a fiery vermilion, and run up Taylor Creek, near South Lake Tahoe. As spawning season approaches, the fish acquire a humpback and protuberant jaw. After spawning they die, and their carcasses provide a feast for gatherings of mink, bears, and bald eagles. The salmon are not native and were transplanted from the North Pacific to Lake Tahoe in 1944. North American beaver were reintroduced to the Tahoe Basin by the California Department of Fish and Wildlife and the U.S. Forest Service between 1934 and 1949. Descended from no more than 9 individuals. 1987 beaver populations on the upper and lower Truckee River had reached a density of 0.72 colonies per kilometer. At the present time, beaver have been seen in Tahoe Keys, Taylor Creek, Meeks Creek at Meeks Bay on the western shore, and Kings Beach on the north shore. So the descendants of the original 9 beavers have apparently migrated around most of Lake Tahoe. Recently, novel physical evidence has demonstrated that beaver were native to the Sierra until at least the mid-19th century, via radiocarbon dating of buried beaver dam wood uncovered by deep channel incision in the Feather River watershed. That report was supported by a summary of indirect evidence of beaver, including reliable observer accounts of beaver in multiple watersheds from the northern to the southern Sierra Nevada, including its eastern slope. A recent study of Taylor Creek showed that beaver dam removal decreased wetland habitat, increased stream flow, and increased total phosphorus pollutants entering Lake Tahoe, all factors which negatively impact the clarity of the lake's water. In addition, beaver dams located in Ward Creek, located on the west shore of Lake Tahoe, were also shown to decrease nutrients and sediments traveling downstream. The lake's cold temperatures and extreme depth can slow the decomposition rate of organic matter. For example, a lost diver was found 17 years later at a depth of 300 feet with his body preserved nearly perfectly. Human history. Native people. The area around Lake Tahoe was previously inhabited by the Washoe tribe of Native Americans. Lake Tahoe was the center and heart of Washoe Indian Territory, including the upper valleys of the Walker, Carson, and Truckee rivers. The English name for Lake Tahoe derives from the Washoe word Daaw, meaning the lake. Exploration and naming. Lt. John C. Fremont was the first person of European descent to see Lake Tahoe during Fremont's second exploratory expedition on February 14, 1844. John Calhoun Johnson, Sierra explorer and founder of Johnson's Cutter, was likely the first white man to see Meeks Bay, and from a peak above the lake he named Fallen Leaf Lake after his Indian guide. His first job in the West was in the government service, carrying the mail on snowshoes from Placerville to Nevada City, during which time he named the lake Lake Bigler in honor of California's third governor John Bigler. In 1853, William Eddy, the Surveyor General of California, identified the lake as Lake Bigler. During the Civil War, Union advocates objected to the name, because Bigler was an ardent secessionist. Due to this, the U.S. Department of the Interior introduced the name Tahoe in 1862. Both names were in use. The legislature passed legislation declaring the official name to be Lake Bigler in 1870, while to most surveys and the general public it was known as Lake Tahoe. The lake didn't receive its official and final designation as Lake Tahoe until 1945. Mining era. Upon discovery of gold in the South Fork of the American River in 1848, thousands of gold seekers going west passed near the basin on the way to the gold fields. European civilization first made its mark in the Lake Tahoe basin with the 1858 discovery of the Comstock lode, a silver deposit just 15 miles to the east in Virginia City, Nevada. From 1858 until about 1890, logging in the basin supplied large timbers to shore up the underground workings of the Comstock mines. The logging was so extensive that loggers cut down almost all of the native forest. Development. Even in the mining era, the potential of the basin as a tourist destination was recognized. Tahoe City was founded in 1864 as a resort community for Virginia City. Public appreciation of the Tahoe Basin grew, and during the 1912, 1913, and 1918 congressional sessions, congressmen tried unsuccessfully to designate the basin as a national park. While Lake Tahoe is a natural lake, it is also used for water storage by the Truckee-Carson Irrigation District. The lake level is controlled by a dam built in 1913 at the lake's only outlet, the Truckee River, at Tahoe City. The 18-foot-high dam can increase the lake's capacity by 744,600 acre-feet. During the first half of the 20th century, development around the lake consisted of a few vacation homes. The post-World War II population and building boom, followed by construction of gambling casinos in the Nevada part of the basin during the mid-1950s, and completion of the interstate highway links for the 1960 Winter Olympics held at Squaw Valley, resulted in a dramatic increase in development within the basin. From 1960 to 1980, the permanent residential population increased from about 10,000 to greater than 50,000, and the summer population grew from about 10,000 to about 90,000. Since the 1980s, development has slowed due to controls on land use, government and politics. After a dispute that included gunshots exchanged between militia in 1864, California and Nevada defined a partition that followed geographical coordinates. The state line runs east of the approximate center line of the lake, at 39 degrees north latitude. The state border runs southeasterly towards the Colorado River. Unbeknownst to the negotiators, this compromise split Lake Tahoe, 2/3 for California, 1/3 for Nevada. In California, Lake Tahoe is divided between Placer County and El Dorado County. In Nevada, Lake Tahoe is divided among Washoe County, Douglas County, and Carson City. As the population grew and development expanded in the 1960s, the question of protecting the lake became more imperative. In 1969, the U.S. Congress and the California and Nevada state legislatures created a unique compact to share resources and responsibilities. The compact established the Tahoe Regional Planning Agency, a bi-state agency charged with environmental protection of the basin through land use regulation and planning. In 1980, the U.S. Congress amended the compact with Public Law 96-551. The law designated a new agency, the Tahoe Transportation District, to facilitate and implement basin and regional transportation improvements, additions for the protection, restoration and use of the lake. Schisms between both agencies and local residents have led to the formation of grassroots organizations that hold to even stricter environmentalism. Historical locations. Lake Tahoe is also the location of several 19th and 20th century palatial homes of historical significance. The Thunderbird Lodge, built by George Whittle Jr., once included nearly 27 miles of the Nevada shoreline. Vikingsum was the original settlement on Emerald Bay and included an island tea house and a 38-room home. The Airman Mansion is a summer home built by a former Wells Fargo president in Sugar Pine Point and is now a state park. Environmental issues. Water quality. Despite land use planning and export of treated sewage effluent from the basin, the lake is becoming increasingly eutrophic, with primary productivity increasing by more than 5% annually, and clarity decreasing at an average rate of 0.25 meters per year. Until the early 1980s, nutrient limitation studies showed that primary productivity in the lake was nitrogen limited. Now, after a half-century of accelerated nitrogen input, the lake is phosphorus limited. Theodore Swift et al. Concluded that suspended inorganic sediments and phytoplanktonic algae both contribute significantly to the reduction in clarity, and that suspended particulate matter, rather than dissolved organic matter, are the dominant causes of clarity loss. The largest source of fine sediment particles to Lake Tahoe is urban stormwater runoff, comprising 72% of the total fine sediment particle load. The urban uplands also provide the largest opportunity to reduce fine sediment particle and phosphorus contributions to the lake. Historic clarity of approximately 30 meters can be achieved with total reduction of approximately 75% from urban sources. Historically, the clarity of Lake Tahoe continued to decrease through 2010, when the average sea depth, 64.4 feet, was the second lowest ever recorded. This represented a decrease of 3.7 feet from the previous year. However, the lake's clarity increased from 2011 to 2014, improving by nearly 20%. A water quality study by the Lahontan Water Quality Control Board and the Nevada Division of Environmental Protection determined the largest source of fine sediment particles. 71% is developed area erosion and runoff, much of it associated with transportation infrastructure and services. Recent research has shown that the urban uplands also provide the largest opportunity to reduce fine sediment particle and phosphorus contributions to the lake. Historic clarity of approximately 30 meters can be achieved with total reduction of approximately 75% from urban sources. Lake Tahoe is a tributary watershed drainage element within the Truckee River Basin, and its sole outlet is the Truckee River, which continues on to discharge to Pyramid Lake. Because of the sensitivity of Truckee River water quality, this drainage basin has been studied extensively. The primary investigations were stimulated by the U.S. Environmental Protection Agency, who funded the development of the DSSAM model to analyze water quality below Lake Tahoe. Lake Tahoe never freezes. Since 1970, it has mixed to a depth of at least 1,300 feet, a total of 6 or 7 times. Dissolved oxygen is relatively high from top to bottom. Analysis of the temperature records in Lake Tahoe has shown that the lake warmed at an average rate of 0.015 degrees Celsius per year. The warming is caused primarily by increasing air temperatures, and secondarily by increasing downward long-wave radiation. The warming trend is reducing the frequency of deep mixing in the lake, and may have important effects on water clarity and nutrient cycling. Ecosystem changes. Since the 1960s, the lake's food web and zooplankton populations have undergone major changes. In 1963–65, opossum shrimp were introduced to enhance the food supply for the introduced kokanee salmon. The shrimp began feeding on the lake's cladocerians, and the populations virtually disappeared by 1971. The shrimp provide a food resource for salmon and trout, but also compete with juvenile fish for zooplankton. Since the 1970s, the cladocerian populations have somewhat recovered, but not to former levels. Since 2006, goldfish have been observed in the U.S.'s second deepest lake, where they have grown to giant size, behaving like an invasive species. They may have descended from former pets which are dumped or escaped when used as fishing bait. In June 2007, the Angora fire burned approximately 3,100 acres throughout the South Lake Tahoe area. While the impact of ash on the lake's ecosystem is predicted to be minimal, the impact of potential future erosion is not yet known. Environmental protection. Until recently, construction on the banks of the lake had been largely under the control of real estate developers. Construction activities have resulted in a clouding of the lake's blue waters. Currently, the Tahoe Regional Planning Agency is regulating construction along the shoreline. These regulations are unpopular with many residents, especially those in the Tahoe Lakefront Homeowners Association. The League to Save Lake Tahoe has been an environmental watchdog in the Lake Tahoe Basin for 50 years. Founded when a proposal to build a 4-lane highway around the lake, with a bridge over the entrance to Emerald Bay, was proposed in 1957. The League has thwarted poorly designed development projects and environmentally unsound planning. The League embraces responsible and diversified use of the lake's resources while protecting and restoring its natural attributes. Since 1980, the Lake Tahoe Interagency Monitoring Program has been measuring stream discharge and concentrations of nutrients and sediment in up to 10 tributary streams in the Lake Tahoe Basin, California and Nevada. The objectives of the LTIMP are to acquire and disseminate the water quality information necessary to support science-based environmental planning and decision-making in the basin. The LTIMP is a cooperative program with support from 12 federal and state agencies with interests in the Tahoe Basin. This data set, together with more recently acquired data on urban runoff water quality, is being used by the Lahontan Regional Water Quality Control Board to develop a program to limit the flux of nutrients and fine sediment to the lake. UC Davis remains a primary steward of the lake. The UC Davis Tahoe Environmental Research Center is dedicated to research, education and public outreach, and to providing objective scientific information for restoration and sustainable use of the Lake Tahoe Basin. Each year, it produces a well-publicized State of the Lake Assessment Report.